Now for this problem, each pulley is free to rotate about its bearing. The weights of all parts are small compared with the load, and we are tasked to compute the value of T, that is the tension of the rope, in pounds. And we are also tasked to calculate the reaction at point O, that is found here, in pounds. Now to begin our analysis, let us label this one here, pulley 1, this is pulley 2, and pulley 3. And let us start analyzing the free body diagram of each pulley, beginning with pulley 1. So at pulley 1, we have a 1 kip force going downward, and a tension that is equal to, let's call this T sub 1. Now these two forces here must be equal by inspection, or you can take summation moment at the center so that you can prove that these two tensions right here must be equal, or you can notice this by symmetry. Now taking summation forces, vertical equal to 0, we have 2 T sub 1 minus the 1 kip force equal to 0. We have 2 T sub 1 equal to 1 kip. Divide both sides by 2, we have T sub 1 equals to, that is 0.5 kips. Now that we have the tension for the first pulley, we can now proceed analyzing the second pulley. So we have pulley 2. So in pulley 2, we have a force of 0.5 kip that comes from the tension from pulley 1. And we have two unknown forces, let's call this T sub 2, that are both equal. So by taking summation of forces vertical equal to 0, we have 2 T sub 2 minus 0.5 kips equal to 0. So let's move the 0.5 kip to the right, and then divide both sides by 2. We get T sub 2 equal to 0.25 kips. Now that we have the value for tension 1 and tension 2, we can now begin analyzing the free body diagram of pulley 3. So at pulley 3, we have the tensile force of equal to 0.25 kips that comes from the second pulley. And this tension right here, since they are connected, must also be equal to 0.25 kips. That is acting at an angle of 30 degrees. And this point here, point O, since it is connected to a pin, therefore it induces a reaction that is both vertical and horizontal. So let's call this Fy and Fx. That is going downward and to the left. Now to solve for Fx and Fy, we take summation forces horizontal equal to 0, and considering rightward forces to be positive, so we have the 0.25 kip force cosine of 30 degrees. And we have Fx that is going to the left, so it's negative, all equal to 0. So we have Fx that is equal to 0.25 cosine of 30 degrees kips. Solving, we get Fx equal to 0.25 cosine of 30 degrees, which is equal to 0.217 kips. Now to solve for Fy, we take summation forces vertical equal to 0. Now the forces acting vertical, we have the 0.25 kip force sine of 30 degrees going upwards, and we have the negative 0.25 kip force going downward, minus the force Fy equal to 0. And we can solve for Fy. So we have 0.25 sine of 30 degrees minus 0.25 minus Fy equal to 0. Chip solving, we get Fy equal to negative 0.125 kips. And the negative sign indicates that our assumption for the direction of Fy is incorrect. Therefore, Fy should be going upwards. So we have the value for Fy and Fx. Now we can proceed solving for the problems that is shown here. Now that you have the value for t that is equal to 0.25 kip, to convert this into pounds, we multiply it by 1000 pound per 1 kip. Or basically, 1 kip is just equal to 1000 pound. So this is our conversion factor. So we can cancel kip, we get 250 pound by multiplying 0.25 and 1000. And to solve for the reaction at point O, we take the square root of the components, that is fx squared plus fy squared, to get the net force at point O. So you have square root of fx is equal to 0.217 kip squared plus the vertical force that is equal to 0.125 kip squared. Let us write the unit later. So solving, we get square root of 0.217 squared plus 0.125 squared. That is equal to 0.25 kip. And multiplying by our conversion factor of 1000 pound per 1 kilopound, we get 250 pounds. And that is the reaction at point O, which is letter A.